Let's solve this equation using quadratic formula. So first of all, we need to get it into proper form. So let's get all the terms on one side, 0 on the other. So we'll get 2m squared plus 5m minus 3 equals 0. And now I can identify there's A, there's B, there's C. So here's the quadratic formula. M, not x, m is equal to, all right, here's how it goes, negative b plus or minus the square root of b squared minus 4ac all over 2a. Let's substitute. M will give us, all right, negative b. Now just read that as the opposite of b. B in this case is 5. So this is going to be, opposite of b is negative 5 plus or minus the square root of b squared. That's going to be 5 squared minus 4 times a, which is 2, times c, which is negative 3. Right, do you see it? B squared, b is 5, so I'll get 5 squared, minus 4 times a, but a is 2, times c, which is negative 3. All right, so if I actually say that up here, a is equal to 2, b is equal to 5, c is equal to negative 3. And I guess we're supposed to actually write that in here, right? A is 2, b is 5, c is negative 3. And then this whole thing gets divided by 2 times a, but a is 2. All right, so some arithmetic here. So we're going to get that m is equal to negative 5 plus or minus the square root of 25. Now what do we get here? Negative 4 times 2 is negative 8. Negative 8 times negative 3 is positive 24. So positive 24 all over 2 times 2, which is 4. So m is going to be negative 5 plus or minus the square root of, how nice, 49 all over 4. M is equal to negative 5 plus or minus 7 over 4. So two numbers here. M is equal to negative 5 plus 7 over 4 and negative 5 minus 7 over 4. So that'll give us negative 5 plus 7 is 2 over 4. Negative 5 minus 7 is negative 12 over 4. So we get 1/2 and negative 3. Again, we're supposed to use the quadratic formula to solve this equation. Now let's get it in the right form, in standard form. So I need everything on the left side, say 0 on the right side. So I'm going to subtract that 10x. So I'm going to get 3x squared minus 10x plus 6. That's equal to 0. Now nothing factors here, so I can identify. A is 3, B is negative 10, C is 6. Right? Here's A. A is the coefficient of the squared term. B is the coefficient of the linear term, linear being exponent of 1, and C is the constant. So here's our formula. X is equal to negative b plus or minus the square root of b squared minus 4ac, all of this over 2a. So let's substitute. So we'll get x equals, all right, now this says the opposite of b, right? The opposite of b. B is negative 10, so I'm going to write it carefully. The opposite of negative 10 plus or minus the square root of b squared. So that's going to be negative 10 squared minus 4 times a, which is 3, times c, which is 6, all over 2 times a, which is 3. All right, let's do this arithmetic. I'll do it up here. So we'll get x equals opposite of negative 10 is 10, plus or minus the square root of, now negative 10 squared is 100. Now what do we get here? Negative 4 times 3 is negative 12. Negative 12 times 6 is negative 72. So this is minus 72 all over 2 times 3, which is 6. Moving on, we'll get x equals 10 plus or minus the square root of, now 100 minus 72 is a 28. all over 6. X is equal to 10 plus or minus. Now that square root of 28, I can break that down. I know a perfect square that goes into 28. 4 goes into 28 7 times. And I'm doing that because I know the square root of 4. I can take that out. All over 6. So x is equal to 10 plus or minus, right, square root of 4, square root of 7, all over 6. X is equal to 10 plus or minus 2 square root of 7 over 6. And I don't think we can really do anything here. Let's just leave it like this. So there's two numbers here. We'll get x is equal to 10 plus 2 square roots of 7 over 6, and 10 minus 2 square roots of 7 over 6. So we're supposed to solve this equation. It doesn't tell us how. It just says solve it. So you know what I'm going to do is I'm going to get everything on one side. So I notice that I've got a squared term on the left and a constant. Let's get this linear term on the left side. So I'm going to get 16z squared minus 96z plus 142 equals 0. These are pretty big numbers here, but they're all even, so I can take a 2 out anyway. So I'm going to take a 2 out, and that'll give me 8z squared minus 48z plus 71. All that's equal to 0. Well, I don't think I can factor that, so I'm going to use the quadratic formula on this. A is going to be 8, B is going to be negative 48, and C is going to be 71. So here's what we'll have. Z is equal to negative B, opposite of B, plus or minus the square root of B squared minus 4AC, all over 2A. So let's substitute. We'll get Z is equal to the opposite of B. Now B is negative 48. So we are going to have the opposite of negative 48 plus or minus the square root of, okay, B squared. That's going to be negative 48 squared minus 4 times A, which is 8, times C, which is 71, all over 2A. A is 16. No, A is 8. Let me get that right. A is 8. Well, we've got some big numbers here. Z is going to be, the opposite of negative 48 is 48, plus or minus the square root. Now, this is 48 squared. On my calculator, I get 2304. Minus, now 4 times 8 is 32, negative 32, minus times 71. All right, so 32 times 71 is 2272. So minus 2272, all over 2 times 8 is 16. So here's where we are. Z is equal to 48 plus or minus the square root. This turns out to be negative 32. All right, up here, 2304 minus 2272 is negative 32, all over 16. Now, this negative 32, well, there's an I coming out here, right, because it's imaginary. So we're going to get 48 plus or minus, now, I times, can you break 32 into two numbers, one of which you know the square root? How about 16 times 2? All over 16. So Z is equal to 48 plus or minus, square root of 16 is 4. So I'm going to write, okay, so I'm going to write it right here. Square root of 16 is 4, so just take a 4 out. So we'll get 4I, we'll be left with a square root of 2, all over 16. Now in the top here, 48 and 4, I can factor a 4 out of that. So I'm going to get Z is equal to 4 times, now take a 4 out. 4 into 48 will go 12, plus or minus, take the 4 out, I'll just get I square root of 2 all over 16. And then this 4 will go into 4 once, into 16 4 times. So here's where we are. z is equal to 12 plus or minus I square root of 2 all over 4. And I'm going to conclude that is the answer. Or if you write it in this form here, a plus bi, which I like to do because it's imaginary. This is the standard form for imaginaries. So if I did that, I'd get this. Z is equal to 12 over 4 plus or minus, say I'm going to write square root of 2 over 4i, right? A plus bi. 12 over 4, that's a 3. So how about z is equal to 3 plus or minus square root of 2 over 4i. So I think either one of these is going to be acceptable. And number 17, this is not going to factor, so I think I'll just go directly to the quadratic formula. So in this case, a is equal to 1, right? A is the coefficient of the squared term, that's a 1. B is the coefficient of the linear term, that's negative 1. And C is the constant, that's a 10, right? A, B, C. So here's what we'll get. X is equal to opposite of b, negative b, plus or minus the square root of b squared minus 4ac over 2a. Let's substitute. X is equal to the opposite of b. Now, careful, all the negatives. B is negative 1, so I'm going to get the opposite of negative 1 plus or minus the square root of b squared, so negative 1 squared, minus 4 times a, which is 1, times c, which is 10, all over 2a, 2 times 1. So let's see, x is equal to, now, the opposite of negative 1 is 1, plus or minus the square root of, now, negative 1 squared is 1, and then what do we get here? Negative 4 times 1 is negative 4. Negative 4 times 10 is negative 40. So minus 40 all over 2. X is equal to 1 plus or minus the square root of negative 39 over 2. Now that 39, I can write that as 3 times 13, but that doesn't help because neither one are squares. So I can't take a square out of that, but I can take an I out. So I'm going to claim now that X is equal to 1 plus or minus I times the square root of 39 over 2. Now that'll work, but I like the form a plus bi. So how about X is equal to 1 over 2 plus or minus square root of 39 over 2i.